Hello, everyone. This is Mr. Bryce, Susquehanna Valley High School here in Concord, New York, and we're going to do test corrections on our Unit 5 test, Part 1. Now, listen, you don't have to follow the questions that you've got perfect scores in. How do you know if you have a perfect score? Well, it tells you how many points the question is worth, and on your paper, it'll tell you how many points you received. So here's question number 1. It says, given the table, find the average rate of change from, well, minute 3 to minute 12. Show all work. Well, when you see average rate of change, I don't care what is happening. You write down delta y over delta x. What does delta y over delta x mean? This is the same thing as saying subtract the y over subtract the x. It says 3 to 12. So I only care, oh my gosh, look at that, that was horrible. It's okay. 3 to 12. Those are the x values. So you can do 12 minus 3 if we're going that way. 12 minus 3. Then on top go the y's. 48 minus 12. If we do bottom minus top, bottom minus top. There it is. 36 over 9. If you want to, you can simplify that to be 4. Ta-da! Question number 2. Given the table above, find the missing value for 20 minutes. Show all work. Well, it's a good thing that we found what the rate of change was. The rate of change is 4 or 4 over 1. Same thing. So it's like for every 4 y's, we change 1 x's. So you can take a look at the relationship with the table, and it's like, okay, are we going to be multiplying or dividing? We have 12, we go to 48. We have 7, we go to 28. Oh, okay. Yeah, we're multiplying by 4. So it's 20 times 4 is 80, and I think it's minutes, right? Yeah, that's it. You got it? You have any questions, make sure you raise your hand. So now if we're working on number 3, this is really picky. Given the graph, interpret what's happening from 6 to 8 minutes in terms of the dependent and independent variables. What does that mean? That means you have to use time in your answer, and you have to use miles or something about distance in your answer. So the answer number 3 is, as the 2 minutes pass or go on or continue or carry on, you know what I'm saying? What's happening? The distance from home stays the same. You understand that? You have to have, in your explanation, you have to have something about time, minutes, or you have to have distance or miles. The miles doesn't change. The distance from home stays the same. Okay, so that's what we're looking at. We have to have the dependent variable mentioned. We have to have the independent variable mentioned by name. Number 4, now it says, given the graph, what is the average rate of change? What did you say? I said average rate of change. What did you say? I said average rate of change from 14 to 20. And what did I say? Question number 1, when you see average rate of change, you write down delta y over delta x. There it is. What? I didn't say delta y over delta x. I said subtract the y's over subtract the x's. Oh, okay, I remember that now. So the minutes is on the x-axis, so I can just put that down there, 20 minus 14. And then when I look up here, the 20 value, what's the y number? 0. So I put a 0 there. And the 14, what is the y value? Go right over there. It's 10. So this equals negative 10 over positive 6. So this is a negative number. Now, does it say to simplify? It doesn't say to simplify. Of course, you can if you want to. Listen, ladies and gentlemen, this is going downhill, going downhill, so we know that there has to be a negative slope there. Change in y, subtract the y's over subtract the x's. So that's what you got to do. Subtract them. I wrote them down. I subtracted them. Read them off the graph. You got it? We're going to, if you have any questions, ask me now. We're going to go on to number 5. Okay, now we're on number 5, A, B, and C. So it says estimate. And we get really close to the value of the function f of -1. Notice the -1 function value at -1. The -1 is inside the parentheses, same as f of x. If you're thinking about it, that's what, okay, there's the x inside the parentheses, so I have to do -1 on the x value. -1 on the x value. There it is. I'm using my ruler. You had a ruler during the test, and it says, where is it about? It's right around -6. So f of -1 equals -6. You got to write this down. The inside number is the x number. Okay, 5b, estimate the value of x when f of x equals 4. Let me see, it's not the inside number, it's the outside. You're writing this down. The outside number is the y. Take my ruler, turn it sideways, or actually horizontal, and now it says f of x is 4. Oh, there are 2 of them. The line is to the left, and the line is to the right. Oh, so the ruler touches the line twice. That's what I'm looking at, where the ruler touches the line. Where the ruler touches the line or the curve. Okay, so the first answer is about right here. That's right about -4. And that one over there is right about 2, 2.1, somewhere in there. So I'm just going to say 2, 2.0. And 5c, estimate the point that represents the minimum of the function to the left. Okay, this function over here, the one on the left right over here. So, okay, where's the minimum? Minimum. No, I'm not at the bottom yet because I'm still touching the blue line. Not at the bottom yet. Oh, wait a minute, Mr. Bryce. You had a redundancy in the question? Yes, but it says the point to the left. Okay, so I know the y value. I know the y value is -6. So when you do a point, you have the x and the y value. Now, do you remember what the x value was? No, so let's just check it again. -1. There it is. -1. What are you going to write down for this one? Minimum lowest point, period. Okay, number 7. Wait a minute. What happened to number 6? I don't know. I don't know what happened. I'm a poor counter. I'm a math teacher, not a counting teacher. Anyway, that's a little joke. What does the point 2015, 50,000 represent? This is the x number. That's the y number. So you have to say the x. You have to say the x. What's the x? Oh, the independent variable. These are the years, right? So in the year 2015. Well, we know it's 2015. You have to say it's 2015 in the year. The year 2015. You don't say year, you don't get the points. There were 50,000. 50,000 what? 50,000 deaths. Or 50,000 deaths due to drugs. Okay. Yes, you have to write what the y, the dependent variable, was about in the explanation. Got it? I hope I stressed that enough. Thank you. Number 8. It takes about 63 years for the population to double. Okay. From the year 1999, how long did it take the death rate from drugs to double? Oh, so this It's interesting information, but has nothing to do with the question. From the year 1999, how long did it take the death rate for drugs to double? Well, in 1999, there were about 18,000 people died from drugs. How long did it take to double? You double 18, and we get 36,000. Where is 36,000? A little bit more than half, right around 2006, 2007. And I got a lot, I mean, okay, if you said 20,000 for 1999, then we looked for 40, and you got an answer all the way up to around 2011, 2012. That is fine, okay? It all depended on how did you figure out your answer. I looked at 1999 and saw it was, what did I see it was? Depends on what, I mean, if you saw that it was 20,000, then great, 20,000. If you saw it was 19,000, then it was 19,000. I saw it was 18,000 and doubled it to 36,000. Then 36,000, abbreviation for thousand is K, kilometer, kilometer. Okay. Then 36K is the year 2006 or 2007 or 2008 or 2011, 2012, whatever you, if you use 20,000. So number 9. Using this doubling function, predict when the number of deaths will be 2,200,000 from drug use. Use of the table is optional. Not the question is optional. Use of the table is optional. If you use the table, you may have to use more or less entries than what are shown here. So in other words, it's just like, hey, you know, maybe you wanted to estimate something else. So I'm going to start with, you can start with 18,000 if you want, but then I'm going to start with 20,000 because it's easy to double. It doubles to 40, and then that doubles to 80, and then that doubles to 160,000, and that doubles to 320,000. Hope you're listening to me and not watching what I'm writing, because I'm certainly not writing very neatly. And then that doubles to 640. What's my goal? 2.2 million. And then that doubles to 128. So that's 1,280,000. Close. And then 2,560,000. Okay, there we go. That's, so the 2.2 million is right about there. Now this was 1999, and it said using this doubling function. Now here, I went from 1999 to 2006. So that's 7 years to double. I could have gone to 2007, which would have been like 8 years, or you can go to 10 years, whatever it was, but it's 7 years. So if this is 1999, then this is going to be 7 years later, 2006. And then I'm going to add 7 to it, and I'm going to get 2013. I'm going to add 7 and get 2020. I'm going to add 7 and get 2027. I'm going to add 7. When am I going to stop? When I get down here. I get 2034. And then I get 2041. And then I get 2048. So it's a little bit before 2048. From the graph between what 2 years, it's up here. If you use the table, it can be more or less entries shown. I predict it will be between 2041 and 2048, closer to 20, 48. So I'm going to say 20, 47. Number 10. From the graph, between what 2 years is the rate of change the fastest? Okay. That means, where is it the steepest? Fastest rate of change. The fastest rate of change is right there. The slowest rate of change is right there. The fastest rate of change is right there. You see the lines that I'm drawing? Those are the fastest and slowest rate of changes. So let's see where there is a steep rate of change. That looks like it's right around 2016 to 2017. Ta-da! Steepest line, 2016 to 2017. Something really close, because I understand that you're reading this graph the best you can, and you steep line or steep curve. Why is this graph not linear, but it is indeed exponential? Linear uh, is straight. I mean, all lines are straight. I mean, I emphasize that all the time. Is straight. This is curved. I also said it's doubling. And a doubling function is always exponential. Wait a minute, when did you say it was doubling? I said it was doubling in question number 9, was it? Yeah, given this doubling trend, okay, right from question number 9, it told you that it's doubling. Why didn't I get full credit for number 11 when I had the right answer written down? Well, because you didn't show any work. All you have to do is show 2, 2.5 squared plus 7, parenthesis 2.5 minus 5. You type that into your calculator exactly the way it looks, and you get 25, and you are done. Number 12, other than the fact that this should say g of x equals absolute value of 2x plus 4, find g of negative 8. Let's type this into our calculator. So the difficulty at hand here was, what are those vertical bars? I already said it once. Do you remember what I said? I said it was absolute value. So you can do this 2 ways. Actually, I'm not even going to do it on this screen right there, but because we have to find g of negative 8. So the first thing on this problem right here, the absolute value bar. How do you get that into the calculator? 2 ways. The quickest way is second, 0, ABS is the first thing that appears. Hit enter. There are the absolute value bars. You do 2, don't do x. Put the x in parentheses. Don't do x. X is negative 8. What? Why is x negative 8? Because it says so right here, negative 8. Okay. Then it says add 4. Actually, I got to close my parentheses. Negative 8 is in parentheses. Then we add 4. We're done. We're outside the parentheses. It equals, bingo, it is 12. How do I show that for work? You do g of negative 8 equals absolute value of 2 times negative 8 in parentheses plus 4, close it, equals 12. Ta-da! Number 13, if w of x equals k times x plus 9 and w of 6 equals 21, then what's the exact value of k? Wait a minute. This says if I plug 6 into the x, the answer is going to be 21. So the answer is 21 equals k times 6 plus 9. That's what it says. If you plug 6 in, the answer is going to be 21. Oh, now solve it. Subtract 9 from both sides. 12 equals, you can write k times 6, or you can write 6k. Then we divide both sides by 6. 2 equals k. Two-part question here. It says, what is the domain? What are the x values of the function given below? Give your answer in interval notation. Interval notation. Or you can have stuff like that. Or stuff like that. Or stuff like that. There we go. Just had to make sure I had all the options. What does this mean? That means open. That means closed. I said that means closed. Here we go. So what's the domain? What's the x's? The x's go all the way from 0 to 24. Now I can see the fact that that was an open circle. But I wasn't so picky when I was grading it. It's an open circle at from 0 to 24. What is the range? So remember that y is the range. The range is y of the function above. Give your answer in set builder notation. Okay, the other one was interval notation. This is going to be set builder notation. I wonder what set builder notation looks like. Oh, set builder notation looks like this. Uh-huh. And then a rule. And then uh-huh. So the first thing we know is that since we're talking about range, we're going to put y in there. If we're talking about domain, we would put x in there. What's the range of the function above? Give your answer in set builder notation. Range, what did I say range was? The y values. The y goes left to right. So here we go. Sorry. It's the vertical. It goes from 30 to 80. 30 to 80. Are there any open circles? That's closed. That's closed. Less than or equal to? Less than or equal to. What goes in there? The y. Okay, ladies and gentlemen, make sure you hand in your test corrections. See you later.